Jai Hind everyone. Jai Hind students. Then space. Okay, just try to order the first sequence. Minus 16, minus 45, 33, 7 and minus 9. What should be the correct order here? चलिए करेक्ट ऑर्डर बताइए. minus 16, minus 45 and we are from least to the greatest one. Which is the least and which is the greatest? Minus 16. Minus 45, 33, 7, comma, minus 9. I have to zoom it, just wait for a minute. Okay, fine. So here I am giving one sequence to all of you. Just try to tell me the next number of the sequence. Okay. Fine. Minus 8. Minus 3, what will be the next number? What will be the next number? Two, very good. Here will come 2. How you are getting 2? Because you people are getting now, I think, that minus 8 plus 3 is minus 8. What we should do in minus 8 so that it become minus 3? We should add 5. Then only we get minus 3. It means we have to add minus 3, we have to add plus 5 together. The next number will be 12. Fine. So you are getting pattern, yes? For example, if I ask you 4, 9, 16, 25, what will be the next two numbers? After this exam, I promise you, those who want to prepare for an NMTC for the next year, some videos I will try to put in a week. What is the next number in the sequence now? Okay, these all are the square numbers. Yes, we are getting 2 square is 4, 9, 16, 25, and the next number is 35, and the next number will be 49. So these all are the observations of patterns. Yes, fine. चलिए, व्हाट इज इंटरेस्टिंग अबाउट टुडेज डेट? विल एनीबॉडी टेल मी? आज का जो डेट है 14/7/21, क्या इसमें आपको कुछ पैटर्न दिख रहा है? सेवन टू ज़ा 14, वेरी गुड, बहुत सारे ऑब्जर्वेशन आ रहे हैं। 7 3 times 21, ओके। एनी अनदर ऑब्जर्वेशन इंस्टेड ऑफ मल्टीप्लिकेशन? एनीथिंग एल्स अदर देन मल्टीप्लिकेशन? मल्टीप्लिकेशन के अलावा कुछ दिख रहा है क्या आपको? Also all are odd numbers. Very good. One more. No, 14 is not odd dear. They are divisible by 7. Yes, ये तो हो गया. 7 plus 7 14. 14 plus 7 21. Okay, 14 plus 7 is equals to 21. तो अब ये क्या हो गया भाई? टू नंबर्स का अगर ऐड कर रहे हैं, सो वी आर गेटिंग द नेक्स्ट नंबर. So what we should call it? Let's see a video on it. So on this particular day, today we are getting this observation. That's why today we are celebrating. We are doing an activity on Fibonacci sequence. Fine. So let's see what it is through a video.
Grammarly can help you write quickly and confidently, so you never have to slow down at work. Stay on top of
Have you ever counted the number of petals on a flower? If you counted them on a flower with petals all intact, you would likely discover that the number of petals is a Fibonacci number. That is, a number from the Fibonacci sequence. Many flowers have 3, 5, 8, 13, or 21 petals, all of which are numbers in the sequence.
Three, 5, 8, 13, 21. Fine.
The leaves of cacti and the seeds of sunflowers are arranged in both left and right-handed spirals. The numbers of seeds or leaves in these spirals are also generally in the Fibonacci sequence. We have two hands, both of which have 5 fingers, and each finger is divided into 3 parts. All of these numbers are also Fibonacci numbers. Moreover, the lengths of the bones in our hands also fit into Fibonacci ratios. So, what's the Fibonacci sequence anyway?
Ratio. You all know about ratio, I think. Will you tell me just what you do with the ratio? Ratio से आप क्या करते हैं?
And why is it seemingly everywhere? The Fibonacci sequence is a series of numbers in which a given number is the result of adding the 2 numbers before it. So, if you start with 0, the next number will be 1, followed by 1, followed by 2, followed by 3, and so on. As you can see, every number in this series or sequence is obtained by adding the two preceding numbers. Individual numbers in this sequence are often referred to as Fibonacci numbers. Mathematically, the Fibonacci sequence is represented by this formula, where n is greater than 1.
F of n, actually any number if you will take, suppose if instead of n, if I take a number, so I will do -1 and -2, like 3 and 2. Yes. Suppose n की प्लेस पर हम क्या ले लेते हैं? Suppose n is equals to 7. तब आप मुझे बताइए क्या करना होगा आपको? 7 - 1 and 7 - 2.
You can use this expression to find any nth digit in the sequence. This fascinating sequence is widely associated with the mathematician Leonardo Pisano, also known as Fibonacci.
Leonardo Pisano, okay, from the Republic of Pisa. He was a mathematician who observed.
He hailed from the Republic of Pisa, which is why he is also known as Leonardo of Pisa, and is considered to be one of the most talented mathematicians of the Middle Ages. At the time, Europeans were still using Roman numbers, while Hindu-Arabic mathematicians were using a different number system that was more robust and efficient. Fascinated by the brilliance of the Hindu-Arabic numeral system, Fibonacci brought it to the Western world in 1202 through his now famous book, Liber Abaci. In the book, he reviewed and compared the Hindu-Arabic numeral system with other systems.
So now we are talking about a man who compared the Hindu-Arabic number with Roman numerals and other number system. Rishi is asking what is the meaning of Fibonacci. Fibonacci, it is based actually on the name of a mathematician and the sequence where what we are doing. Just wait for a minute, Rishi.
Such as Roman numerals, and described how using the Hindu-Arabic system made calculations faster and easier. Although his book contains the earliest...
Okay, so Hindu-Arabic system, our Indian mathematicians, they were doing the calculation easier and faster.
...known description of the Fibonacci sequence outside of India, it was described in ancient Indian texts by mathematicians as early as the 6th century. So, what makes this Fibonacci sequence so special? To the uninitiated, this famous sequence may just seem like a series of numbers, but the Fibonacci sequence has been discovered and rediscovered in various forms. Initiated mathematicians as early as the 6th century. So, what makes this Fibonacci sequence so special? To the uninitiated, this famous sequence may just seem like a...
Here, what we have observed in the sequence, the addition of the previous two, like 0 plus 1. 0 plus 1 is 2. Now 1 plus 2. 1 plus 2 is 3. 2 plus 3 is 5. 5 plus 8. What will be the next number?
A series of numbers. But the Fibonacci sequence has been discovered and rediscovered in various forms, not only in mathematics, but also all across the natural world and in our everyday lives. Tell us in the comments below. Which is represented by the Greek letter Phi. The earliest known description of the Fibonacci sequence outside of India, it was described in ancient Indian texts by mathematicians as early as the 6th century. So, what makes this Fibonacci sequence so special? To the uninitiated, this famous...
Yes, 0 plus 1 is 1 only.
So, what makes this Fibonacci sequence? This sequence may just seem like a series of numbers, but the Fibonacci sequence has been discovered and rediscovered in various forms, not only in mathematics, but also all across the natural world and in our everyday lives. There's also another exciting offshoot of the Fibonacci sequence, the golden ratio. Suppose you have two quantities, A and B, wherein A is greater than B. Now, add A and B and divide that sum by A. If this ratio comes out to be equal to the ratio of A and B, then you can say that A and B have a golden ratio, which is represented by the Greek letter.
the sum of 2 divided by the first number. Suppose if we take two numbers, okay, in the sequence like 2, 3 and 5. Fine, just wait for a minute. Which numbers you are taking? Suppose 2, comma 3. The next number in the sequence is 5. So 2 plus 3 is equals to 5. Now what we have to do? We have to divide this sum by the first number. What is the ratio you are getting? Divide all of you 5 by 2. 2.5. And now when you divide the first number by second number, what you are getting? Two 1 times 2. Yes, we get 0.66.
5. Write down the Fibonacci sequence on a piece of paper and calculate the ratio using this form.
Look here, जैसे इन्होंने previous two numbers, okay, जैसे अभी हम क्या कर रहे हैं 3 को 2 से डिवाइड करें. इसी सीक्वेंस में जब हम नंबर ले रहे हैं, चलिए फिबोनाची सीक्वेंस आप मुझे बताइए सबसे पहले तो फ्रॉम, अगर मैं ले रहा हूं सपोज 5 and 6, what will be the next number? ऋषि डिवाइड बेटा, आप अगर उसको डिवाइड करेंगे 2 को 3 से तो आपको क्या मिलेगा? आप पूछ रहे हैं, इतना हमने डेसिमल पढ़ लिया. आप पॉइंट लेंगे, यहाँ पर 0 आ जाएगा आपके पास. 3 6 18. Then when you subtract again you will get 2, and again point is there, तो आप क्या लेंगे? 0, फिर आ जाएगा 6. ये जो प्रोसीजर है भाई ये कंटिन्यू होगा. ओके, अच्छा तो अभी आप सब क्या कर रहे थे? यू आर डिवाइड टेलिंग मी द नेक्स्ट नंबर इन दिस सीक्वेंस. डिवाइड बाय 2 तो 1.5 हो जाएगा. 5 and 6 is 11. ओके, अब हम क्या करते हैं, चलो प्रीवियस नंबर से डिवाइड करेंगे. जैसे कि 11 डिवाइडेड बाय 6, व्हाट इज द आंसर? टेल मी. 1.83 है ना। तो इसी तरह से क्या होगा, देखिए आप ये नियरली जा रहे हैं 1.625.
You will notice that all Fibonacci numbers
See 1.61, 1.6190, ये डिवीजन
have the golden ratio, the value of which is close to 1.618033. In geometry, when the golden ratio is
okay, so what is the golden ratio? 1.618033 when he divides two numbers, okay, which are in the sequence one after the another, and if we are getting nearly 1.61833, we calling it golden ratio.
In geometry, when the golden ratio is applied as a growth factor, you get a special type of logarithmic spiral, known as a golden spiral. Simply put, a golden spiral gets wider by a factor of 5 for every quarter turn it makes. You can find examples and manifestations of the golden ratio and golden spirals in countless places in your everyday life. Seashells are some of the most common examples of the golden spiral found in nature, but ocean waves, hurricanes, flower bugs, snail shells, and spider webs are just a few of the other naturally occurring examples. Many artists use the golden ratio or the golden spiral in their creative works. Legendary painter Salvador Dali explicitly used the ratio in his masterpiece, The Sacrament of the Last Supper. Architects also commonly use the golden ratio when designing buildings and other massive structures. Popular Swiss-French architect Le Corbusier, who is widely acclaimed as one of the pioneers of modern architecture, explicitly used the golden ratio in his modular system. From snail shells, flowers, and bananas to the inside of the human ear, iconic buildings, and galaxies far out in the cosmos.
See, this ratio what we taught, कि जब एक पैटर्न में कोई चीज बढ़ती है ना, अभी हमने देखा कि 0 1 1, आई थिंक फिबोनाची सीक्वेंस तो सभी को समझ में आ रहा है. When you have, चलिए एक बार आप सब पहले मुझे फिबोनाची सीक्वेंस बता दीजिए. If I am starting from 0 1, what is the next number? 1 plus 0 is 1. Now 1 plus 1, 2. 2 plus 1, comment fast. 3. 3 plus 2, 5. 5 plus 3, 8. 5 plus 8, 13. 13 plus 8, 21. 21 plus 13, 34. ओके, तो क्या हो रहा है, बस इतनी सी बात है कि जो एक नेचर में हम जितनी चीजें देख रहे हैं ना, जैसे वो एक स्पाइरल रोटेट हो रहा है ना. तो अब स्पाइरल में क्या हो रहा है कि वो इस सीक्वेंस में बढ़ रहा है. कोई चीज 1, फिर उसको कर रहे हैं 2 टाइम्स, देन 3, देन 5, देन 8. तो इस तरह से वो एक अनएंडिंग सर्कल हमें मिलता जाएगा. अभी ये जो गोल्डन रेशियो है, इस पे और आप
The golden ratio can be seen everywhere. This is probably why it's also known as the divine proportion. There are so many places to find the golden ratio or Fibonacci numbers that it's impossible to list all of them in one place, and the list is ever growing. What other examples of the Fibonacci sequence or the golden ratio have you observed in your life? Tell us in the comments below.
Good grammar and spelling are important, but if you want to write essays that inspire,
okay, I think all of you are knowing what is TED. Okay, TED Talks are there. TED Talks में आप अपना login कर सकते हैं and you may explore it for different topic videos. जो आप साइंस में, मैथ्स में जो टॉपिक पढ़ते हैं ना, तो किसी एक छोटे से टॉपिक को आप डालेंगे and you will get amazing video or the discussions on those topics.
So why do we learn mathematics? Essentially for 3 reasons: calculation, application, and last and unfortunately least in terms of the time we give it, inspiration.
See what a beautiful aspect here. Why do we learn mathematics? Okay, mathematics हम सब क्यों पढ़ते हैं भाई? हाँ, that is a channel name. So the three things are here: calculation, application, and inspiration. हमको math inspire करता है, yes, to go for something new, to make something crazy. ये जो inspire वाला part है ना, on this only we want to work. ठीक है ना? कैलकुलेशन तो हम सीख जाते हैं जल्दी से, तो हम किस पे काम करना चाहते हैं? Want to work on application and inspiration. Inspiration हमें कहाँ से मिल रही है? These two things. So please help me out and help yourself also. है ना? आप मुझे भी हेल्प करते हैं, मुझे बड़ा मजा आता है जब आप कोई नई चीज बताते हैं, कुछ एप्लीकेशंस आप ढूंढ लेते हैं किसी चीज की, चाहे फिर वो इंटीजर्स हो या फ्रैक्शन हो, डेसिमल हो. देखो टॉपिक सेम है ना, हर साल 7th में स्टूडेंट्स पढ़ते हैं फ्रैक्शन, डेसिमल्स, बट हाउ मेनी ऑफ द स्टूडेंट दे गो फॉर एप्लीकेशन? कितने बच्चों ने उसका एप्लीकेशन देखा? हाउ मेनी गेट इंस्पायर्ड फ्रॉम इट?
Mathematics is the science of patterns, and we study it to learn how to think logically, critically, and creatively. But too much of the mathematics that we learn in school is not effectively motivated. And when our students ask, why are we learning this? And they often hear that they'll need it in an upcoming math class or on a future test.
Okay, see generally the maths teacher will tell, अभी आप पूछेंगे तो क्या बोलेंगे हम कि भैया ये आगे आपकी क्लास में आने वाला है, suppose in 9th you are using 7th class math, okay, और in a future test आप कोई भी competitive exam देंगे तो वहाँ पर भी मैथ्स की रीजनिंग आती है, मैंने आपको ऑलरेडी बताया है ना? I will share also with you like banking, railways का आप अगर एग्जाम देंगे तो वहाँ मैथ्स रीजनिंग में 7th 8th का जो आपका मैथ्स है ये आता है.
But wouldn't it be great if every once in a while we did mathematics simply because it was fun or beautiful or because it excited the mind? Now, I know many people have not had the opportunity to see how this can happen, so let me give you a quick example with my favorite collection of numbers, the Fibonacci numbers. Yeah, already the Fibonacci fans here, that's great. Now, these numbers can be appreciated in many different ways. From the standpoint of calculation, they're as easy to understand as 1 plus 1, which is 2. Then 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and so on. Indeed, the person we call Fibonacci was actually named Leonardo of Pisa, and these numbers appear in his book, Fibonacci, which taught the Western world the methods of arithmetic that we use today. In terms of applications, Fibonacci numbers appear in nature surprisingly often. The number of petals on a flower is typically a Fibonacci number, or the number of spirals on a sunflower or a pineapple tends to be a Fibonacci number as well. In fact, there are many more applications of Fibonacci numbers, but what I find most inspirational about them are the beautiful number patterns they display. Let me show you one of my favorites. Suppose you like to square numbers. And frankly, who doesn't? Let me show you. Let's look at the squares of the first few Fibonacci numbers. Okay, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 5 squared is 25, and so on. All right, now, it's no surprise that when you add consecutive Fibonacci numbers, you get the next Fibonacci number, right? That's how they're created. But you wouldn't expect anything special to happen when you add the squares together. But check this out. 1 plus 1 gives us 2, and 1 plus 4 gives us 5. And 4 plus 9 is 13, 9 plus 25 is 34, and yes, the pattern continues. In fact, here's another one. Suppose you wanted to look at adding up the squares of the first few Fibonacci numbers. Let's see what we get there. So 1 plus 4 is 6. Add 9 to that, we get 15. Add 25, we get 40. Add 64, we get 104. Now look at those numbers. Those are not
6, 15, 40 and 104. Are you getting something special about them? 6, 15, 40 and 104.
Fibonacci numbers, but if you look at them closely, you'll see the Fibonacci numbers buried inside of them. You see it? I'll show it to you. 6 is 2 times 3, 15 is 3 times 5, 40 is 5 times 8, 2, 3, 5, 8. Who do we appreciate? Fibonacci, of course. 2.
Okay, so these addition, squares addition. पहले हमने क्या किया? We did the square of the Fibonacci numbers, and then if we add some Fibonacci number in a sequence, है ना, consecutive addition. अभी हम linear simple equation में पढ़ेंगे consecutive, the sum of 3 consecutive number which are coming one after another. जैसे 114. So 114 is 6. 1 plus 1 plus 4 plus 9 is 15. The next, if you add 25, which is a square of 5, so you got 40. And these, if you break them, we are getting the product. So see how he observed actually. है ना, हम ये बात कर रहे हैं कि उसने observation किस तरह से किया. So when he broke that number again, so he got as the product of Fibonacci numbers.
3, 5, 8. Who do we appreciate? Fibonacci, of course. Now, as much fun as it is to discover these patterns, it's even more satisfying to understand why they are true. Let's look at that last equation. Why should the squares of 1, 1, 2, 3, 5, and 8 add up to 8 times 13? I'll show you by drawing a simple picture. All right, we'll start with a 1 by 1 square, and next to that put another 1 by 1 square. Together they form a 1 by 2 rectangle. Beneath that, I'll put a 2 by 2 square, and next to that, a 3 by 3 square.
Okay, these are the squares, and the number is inside and the square there. Okay, one square, then it becomes 2. First of all, you saw the rectangle.
Beneath that, a 5 by 5 square, and then an 8 by 8 square, creating one giant rectangle, right? Now let me ask you a simple question. What is the area of the rectangle?
Okay, please comment the area of the rectangle if you are getting here. What is the length and what is the breadth here?
Well, on the one hand, it's the sum of the areas of the squares inside it, right? Just as we created it. It's 1 squared plus 1 squared plus 2 squared plus 3 squared plus 5 squared plus 8 squared, right? That's the area. On the other hand, because it's a rectangle, the area is equal to its height times its base. And the height is clearly 8, and the base is 5 plus 8, which is the next Fibonacci number, 13. Right? So the area is also 8 times 13. Since we've correctly calculated the area 2 different ways, they have to be the same number. And that's why the squares of 1, 1, 2, 3, 5, and 8 add up to 8 times 13. Now, if we continue this process, we'll generate rectangles of the form 13 by 21, 21 by 34, and so on. Now check this out. If you divide 13 by 8, you get 1.625. And if you divide the larger number by the smaller number, then these ratios get closer and closer to about 1.618, known to many people as the golden ratio, a number which has fascinated mathematicians, scientists, and artists for centuries. Now, I show all this to you because, like so much of mathematics, there's a beautiful side to it that I fear does not get enough attention in our schools. We spend lots of time learning about calculation, but let's not forget about application, including perhaps the most important application of all, learning how to think. If I could summarize this in one sentence, it would be this. Mathematics is not just solving for X, it's also figuring out Y.
Not the letter Y, it's WHYY. Okay? We just always go for Y, whether it is science or math. We just want to think why it is happening. So it clicks to our mind. Thanks everyone, and I hope that all of you got some inspiration. Go for the applications of the topics which we are studying. Fine.
Thank you very much.
You may explore these TED videos for educational aspect. You will get. I told you, आप कोई एक topic डालिए, and you will get so many beautiful content on it. Fine. Okay, so thank you everyone, and just feel your attendance. And I am going to share one of the quiz as an assignment to try to submit it. Submit your attendance, dear students.